Look up on a clear night. What do you see? Stars. Thousands of them. Millions if your eyes were powerful enough. Now, here's a question so simple a child could ask it, but so deep it nearly broke 19th century science. If the universe is filled with billions of stars, why is the night sky dark? Because the answer? It's not what you think. It touches on the age of the universe, the speed of light, the Big Bang, and one of the most mind-bending ideas in all of cosmology. Okay, first instinct. Space is dark because it's space? Because stars are far away and their light dims over distance. That sounds reasonable. Makes sense. Move on, right? Here's the thing. Yes, light does get dimmer with distance. That's called the inverse square law. Double the distance, you get 1/4 the light. But here's the problem. As you look farther out into space, yes, each individual star gets dimmer. But there are also exponentially more stars. Every time you double your distance, you're looking at a sphere 4 times bigger, which contains roughly 4 times more stars. Those two effects, dimmer per star, but more stars, they cancel each other out. So if the universe is infinite and filled with stars in every direction, then in theory, every single line of sight from your eye should eventually hit a star. Every direction, every patch of sky. The sky shouldn't just have stars in it. The sky should be as bright as the surface of a star. The entire night sky should be blinding white. And yet, it's dark. This is called Olbers' paradox.
In 1823, a German astronomer named Heinrich Wilhelm Olbers formally posed this question. Though he wasn't actually the first. Kepler brought it up in 1610, and Halley, yes, Halley's Comet Halley, wrestled with it too. But Olbers made it famous. And for decades, scientists struggled. Some said maybe dust clouds block the light? Nope. Dust absorbs light and re-emits it as heat. Over infinite time, the dust itself would glow. Some said maybe stars aren't evenly distributed. Still doesn't work. You'd need a very precise, almost impossibly tuned distribution to make it work. Some people just didn't have an answer. They accepted it as a mystery and moved on. But the real solution, it didn't come from studying stars. It came from understanding the universe itself. Here's where it gets wild. The solution to Olbers' paradox rests on 2 connected facts about our universe that we now take for granted, but which would have been unthinkable to astronomers just 200 years ago. Fact 1. The universe has a finite age. The Big Bang happened approximately 13.8 billion years ago. Before that, no matter, no space, no time as we understand it. This matters enormously because light travels at a fixed speed, roughly 300,000 kilometers per second. So there's a maximum distance from which light could have possibly reached us by now. That's called the observable universe, a bubble roughly 93 billion light years across. It's bigger than 13.8 billion years ago because space itself has been expanding. We'll get to that. Beyond the edge of that bubble, light from those stars simply hasn't had time to reach us yet. So even if there are infinite stars out there, we can only see the ones whose light has had time to reach us yet. And that's a finite number. Darkness explained? Partly, but there's more. Fact 2. The universe is expanding and accelerating. In 1929, Edwin Hubble discovered that galaxies are moving away from us, not because they're flying through space, but because space itself is stretching. This is the expansion of the universe. And here's the wild implication. The farther away a star is, the faster it's receding from us. When something moves away from you, its light waves get stretched. The wavelength gets longer. It shifts toward the red end of the spectrum. Far enough away, that light gets stretched so much it slides out of the visible spectrum entirely, into infrared, into microwave radiation. You can't see it anymore. It's still there. The energy is still arriving, but your eyes, or even most telescopes, can't detect it as visible light. So, the finite age of the universe limits how far we can see,
And the expansion of the universe dims and redshifts the light from distant sources. Together, these two facts explain why the sky is dark. Here's a beautiful way to think about this. When you look up at the night sky, you're not seeing the universe as it is. You're seeing it as it was. The moon you see? That's the moon 1.3 seconds ago. The sun? 8 minutes ago. The nearest star, Proxima Centauri, 4.2 years ago. The Andromeda Galaxy, 2.5 million years ago. When we look at the most distant galaxies with something like the James Webb Space Telescope, we're seeing light that left those galaxies over 13 billion years ago, when the universe was just a few 100 million years old. We're not looking across space. We're looking back in time. And here's the thing. Those early galaxies, many of them no longer exist in the form we see them. They merged, evolved, exploded. We're seeing their ghost light. There's something almost philosophical about that. Every night sky observation is a history lesson, a fossil record written in photons.
Here's a twist worth sitting with. Space isn't actually dark in the way we usually mean. Space is absolutely filled with radiation. It's just mostly invisible to us. The most dramatic example, the cosmic microwave background, or CMB. This is the afterglow of the Big Bang itself. About 380,000 years after the Big Bang, the universe cooled enough for atoms to form and light to travel freely for the first time. That ancient light is still washing over us right now. If your eyes could see microwave radiation, the entire sky would glow uniformly, a near perfectly smooth, faint shimmer in every direction. It's not dark, it's invisible to us. Galaxies are blasting out radio waves. Black holes are screaming in X-rays. Neutron stars pulse in gamma radiation. The universe is incredibly loud, in frequencies we can't see. Space isn't dark because it's empty. It's dark because human eyes evolved to detect a very narrow band of the electromagnetic spectrum. Outside that band, the cosmos is ablaze. Now, if you want to talk about real darkness in the universe, let's talk about dark matter and dark energy. Here's a staggering fact. Everything you've ever seen, touched, tasted, or measured, every star, planet, gas cloud, black hole, your phone, your body, makes up just 5% of the total energy content of the universe. 5%. 27% is dark matter, stuff we can't see, can't detect directly, but know is there because of its gravitational effects on galaxies. Without it, galaxies wouldn't hold together, they'd fly apart. And 68% is dark energy, a mysterious force that's driving the accelerating expansion of the universe. We don't know what it is, we know it exists, and it's the dominant feature of the cosmos. So when we ask why is space dark, maybe the deeper answer is because most of what makes up the universe is fundamentally invisible to us. Not just because we lack the instruments, but because it doesn't interact with light at all. The universe is dark because we're only equipped to perceive a thin sliver of reality.
Let me offer you something different, not a scientific answer, a poetic one. The American writer Edgar Allan Poe, yes, that Edgar Allan Poe, actually came remarkably close to solving Olbers' paradox in 1848. In an essay called Eureka, he suggested that the sky is dark because the universe hasn't existed long enough for light from all stars to reach us. A poet, intuiting what scientists wouldn't confirm for another century. There's something profound about the darkness. Every photon of starlight you see tonight left its source years, centuries, or billions of years ago. It traveled at the cosmic speed limit across unimaginable distances, threading through the void, dodging galaxies and black holes and clouds of dust, and landed on your retina. You are the destination. So, why is space dark? Because the universe has a finite age, so light from distant stars hasn't reached us yet. Because the universe is expanding, stretching and dimming the light from faraway sources.